All right, so let's see how we've done with the last two lessons, because that's really what's going on here is two lessons are getting all wrapped up and interconnected. What'd you get for number one? We'll start with Tyler, Destiny, and then Abby.
20x to the 14th power and y to the negative 13th power over 27.
Okay.
20x to the 14th times y to the negative 13th over 27.
Okay, Abby. So you two got the same thing, Abby. Okay. So the correct answer is 20x to the 14th power over 27y to the 13th. However, if you put 20x to the 14th power y to the negative 13th over 27, I will accept that as well. I will accept that. Number two, what did you get? We'll start with Ashley, Avanti, and then Brandon.
X equals 8 and y equals 3.
Okay. You got the same thing?
X equals 8 and y equals 3.
X equals 8 and y equals 3. So, let's start with number two because number two is actually a challenge question. Ashley, how'd you figure that out?
I was like finding out numbers that would equal 5 when you subtract them.
Very good.
And then, like, some of them didn't work for the second one, so then I did 8 minus A was 5, and then I plugged it into the second one.
And it worked. Can you give me an example of one that didn't work, that you tried out?
10 and 5.
Okay, so you plugged in a 10 here, you plugged in a 5, and that does equal this, but then you plugged it in here, and then it didn't work, so you said, okay, that's not it, and then you went to the next one. Very, very good approach. So that's really called, it's called guess and check, but you had to know how this worked to be able to go to that step. So that was great. Anyone do it differently? Well, this is actually an example of systems of equations. That's actually what it was really supposed to be, but what I expected most of you to do what Ashley did. But if you think about it, you can make an equation out of this. X minus y must equal 5. X plus 2 minus 2y must equal 4. That is a system of equations. Solve the system. When you solve the system, you get that. Did I expect that you would automatically know that? No, of course not. But systems can be used for a lot of different situations. Okay? Again, just to reiterate, I expected you to use guess and check, and if you were successful, great. If you weren't sure what to do, that's understandable. It was a challenge question. Number one, I want to go over how we got this answer. Sorry, excuse me. So, the first thing you needed to do was understand that there was nothing that could be simplified here. So leave it alone. Hopefully then you rewrote or wrote the question with the multiplication dots so that you could make sure you saw that 10 was going to be brought to the second power, x to the 7th to the second power, 9 to the second power, and y to the 8th to the second power. So it seems like a lot of us got that. Okay? So I'm going to continue down here. And so you end up with 3 times y to the 3rd over 5 times, and we've got 10 squared, which is 100, x to the 7th to the 2nd. What does that become? Tanya?
X to the 14.
X to the 14th. Very good. Over, and now we've got 9 to the 2nd, which is 81. And we got y to the 8th to the 2nd. What do we get when we do that? Arun?
You get 16.
Y to the 16th power. So this is where some students weren't sure what to do. I know we haven't seen a case of a smaller exponent on top with a larger exponent on the bottom. But my method still applies. How many y's are there on the top? How many y's are there on the top? Tanelia? There's 3. How many y's are on the bottom? 16. So take 3 from here to get rid of the 3 up there. This now becomes 13. There's no x's anywhere except right here, so that's going to be left alone. So now I've got x to the 14th and I've got y to the 13th. Okay? What many of you did was you used the division property where you did 3 minus 13, and that's how you got y to the negative 13th. So that's perfectly okay, but we don't write answers with negative exponents, and that's something you're going to learn today. So I accepted it for now, but today you'll learn how to avoid that. Here was where some of you got tripped up. You should have seen this 3 and this 81 and realized that they had common factor. And you should have said to yourself, oh, well, 3 divided by 3 is 1, 81 divided by 3 is 27. And then, if you look closely at the 5 and the 100, you should have realized that there was a common factor there as well. 5 divided by 5 is 1, 100 divided by 5 is 20, and now just rewrite it in simplest form. Was that easy? Of course not. But this is the level of work that you are expected to be able to handle. Okay? Comments or questions on how either of these were done?
Even if you didn't simplify it and you went forward like straight, then it would come out to 300 over 405.
That's right.
And that would be equivalent to 60 over 81.
But 60 and 81 have a common factor of 3. 60 over 81, that's great work, but that's not in simplest form. Divide by 3, divide by 3, that's 20 over 27. So unfortunately, everything must be in simplest form. Okay? Comments, questions? Okay, put the warm-up to the side and take out the last lesson. Today you're going to be introduced to the idea of an exponent of 0, and you're going to be introduced to the idea of a negative exponent. You're also going to learn how to work with them. So, let's start with 0 as an exponent. The way I always say it, anything to the 0 power is equal to 1. You're going to get an explanation for why this is true in a few minutes. I'm not going to go into an explanation yet. What I want you to take away right at this moment is that anything to the 0 power equals 1. So, as a model here, in the middle, a to the 0 power equals 1. But 4 to the 0 power equals 1. Negative 9, a negative number to the 0 power equals 1. A variable to the 0 power equals 1. Anything to the 0 power equals 1. Some of you might be, your instincts would say, well, wouldn't it be 0? You're going to see in a few minutes why it is not. Yes?
Under the definition, it says a non-zero number, so what would 0 to the 0?
Yeah, I'm going to be looking it up more in depth. I think 0 to the 0 power is also equal to 1, but I have to double check with a more scientific source. So it does say a non-zero number, Don't worry about that, and don't worry about 0 to the 0 power because you're not going to see it on any test or quiz. Okay? So, quite honestly, in the scheme of everything we're studying right now, anything to the 0 power, that's easy. Okay? So, the more challenging aspect for today is a negative exponent. And conceptually, it's going to take you a little time to understand. When you have a negative exponent, it really means the reciprocal. And this is going to take a little time for your brain to wrap itself around. This is one of the ideas where you as a bright young person, you're not going to instantly understand. It's going to take you some time. So, a to the negative n is the reciprocal of a to the n. Notice that there's no negative here, but there's a negative here. That's a critical piece. So, how do you write a reciprocal? You flip it, right? It's a fraction that gets flipped. So a to the negative n really means 1 over a to the n. Notice that there is no negative here, but there is a negative here. Again, that is a critical piece. Right now, your brain is resistant to the idea. Your brain is saying, I don't like that. That doesn't make any sense. But I'm going to show you in a little while why it makes sense. So, 5 to the negative third power really means 1 over 5 to the third power. Once you do the reciprocal, you drop the negative sign. Now simplify. 5 times 5 times 5 is 125. Okay? With an algebraic expression, x to the negative 6th really means 1 over x to the 6th. Once you flip it, you drop the negative. Here's where things are going to get even more challenging. What if you have a negative exponent on the bottom to begin with? 1 over a to the negative n. That means the reciprocal of this whole expression. So you flip it, and you drop the negative. So if it helps you conceptually, really there's a 1 here. But you know that when you write something as the final answer, you don't put the 1. Okay? So we're flipping things. I'm also going to say it a little bit differently in a little while, but we'll get to that in a moment. And another example, 1 over x to the negative 12th really means x to the 12th. Again, negative symbol gets dropped when you flip it. Okay? Normally, I would say, are there any questions at this point? I know there are questions at this point. I know what the human brain is inclined to do. So I'm going to ask you to just be patient and stick with me because the explanation is coming. Okay? So, I would like you to write the following string of exponents down your paper. You don't have to leave as much space as I did. So, we're going to start right here. Could someone tell us what is 2 to the 0 power based on what I've taught you so far? Your mom? It's 1. Why is it 1? So what I want you to do is don't write it down, but I want you to pretend that there's an equals 1 right there. Don't write it, but put it in your brain. So now let's go back up to the top. What is 2 to the third power? Someone tell us, what is 2 to the third power? Martin? 8. 2 to the third power equals 8. 2 to the second power. What is that equal to? Homero? 4. How do we get from here to here? How do we get from the first number to the second number? Ashley? Divide by 2. Please make sure you write that down. Let's continue. 2 to the first power. What is 2 to the first power equal to? Tanya? 2. How do we get from 2 to the second power? How do we get from this 4 to this 2? Austin? Divide by 2. So we've established a pattern. We are dividing by 2 to get to the next answer. So we take this answer, divide by 2, we get the next one. Take this answer, divide by 2, and get the next one. Anyone see where I'm going with this? Divide by 2. What will we get for this answer? Majesty?
1.
You get 1. So 2 to the 0 power must equal 1. So there's your explanation for 0 power. The next one you do not have to write down, but I just want to show you that it works no matter what number you use. So I'm going to do this quickly. 10 to the third power is 1,000. 10 to the second power, 100. 10 to the first power is 10. How do we get from one to the next? What is the pattern that's being established? Abby? Yeah, we're dividing by 10. Divide by 10, divide by 10. So continue the pattern. Divide by 10, 10 divided by 10, again, you get 1. So it works no matter what. I'm not going to do it, but I do have an example with negative numbers just in case someone wanted to argue that maybe it wouldn't work, but it does. It works with all numbers. The pattern can be established. Okay? Comments or questions at this point? Destiny.
So does that mean whatever the base is what you divide by each time?
That's a very good observation. This is the base of 10, so we're dividing by 10. This is the base of 2, we're dividing by 2. All sorts of patterns here. So now, let's take the idea and let's figure out negative exponents. We're going to continue the pattern. Let me hide this. Continue the pattern. So we're going to divide by 2 again. What do we get? Some very hesitant hands. Brandon?
1/2.
Yeah. You get 1/2. 1 divided by 2 is 0.5 or 1/2. What is the exponent on that number right there? There is no exponent, but there is. What is it? Only 3 people have an idea. Nicole? Yeah. So this is really 1 over 2 to the first power, and so what you should be looking at is this right here. The negative 1, we flipped it, and it became a positive 1. Let's continue the pattern, and here's where it gets a little bit difficult, but now divide by 2 one more time. What do we get? Austin? Yeah, you get 1/4. So some of you might be saying, well, Mr. Gallant, your whole explanation just broke down because we got 1/4. Does anyone know what we're going to do at this point? What's another way to write 1 over 4? What could I write instead of the 4? Arun?
1 over 2 to the second power.
Yeah, 1 over 2 to the second power. And again, you are looking here and here. And that is why negative exponents work the way they do, and that is why zero exponent works the way it does. Comments and questions at this point for anything that I'm demonstrating right here.
So why don't we just say negative?
Why don't we say negative reciprocal?
No, like we're saying just the reciprocal, but can't we just say negative reciprocal?
Well, that might confuse some people because then some people might some people might think you mean negative 1/2. So I understand your instinct, and you're right, it is similar to that idea that we used a long time ago. That was for perpendicular lines, right? The slope was a negative reciprocal. We flipped it and flipped the sign. It's similar, but it's not. Okay? Question, Ashley? Oh, okay. So, this is different than anything you've ever done. So that's the explanation of why. So now you should have a little bit of grounding into the why. So now we need to know how to actually work with them. Put it into practice. So, we have a multiplication problem. We have negative 2 to the 0 power times 1 over 4 to the negative second. So let's pretend that that second part is not there, and let's just deal with it one piece at a time so that we can have some sanity. What is negative 2 to the 0 power? Martin? 1. So this is going to become a 1. If that was all that we had, that would be it. Okay? But there's this other piece here, and we need to know how to deal with that. So what you learned so far is that a negative exponent means reciprocal. So what we have to do is, since it's just a simple fraction, is we have to flip it and get rid of the negative on the exponent. So what is this going to turn into? What's that going to turn into? Nirmala?
4 to the second.
Exactly. Times 4 to the second power. So again, we flipped it and got rid of that. Okay? So, now simplify completely. 4 to the second power is 16. 1 times 16, 16. That is simplest form. Comments or questions? Okay. So now we have, in part B, some choices. We actually have, I can think of 4 different ways to do it. But let's try and keep things simple. We have 2 expressions, 2 powers with the same base. 2 lessons ago, you learned something that you do with 2 powers of the same base. What did you learn that you can do? Juliana? Add what? Yes, that's very important. Add the exponents. So 3 to the 5th power, 3 to the negative 7th power, add the exponents. So that will become 3 to the negative 2nd. 5 plus negative 7 is negative 2. But again, negative exponents. We do not write your answers with negative exponents. So we have to now do the reciprocal. Same idea here, except going the other direction. So now, this is going to come this way, and we're going to make it positive. So what will this become? Tanya?
1 over 3 squared.
Yeah, 1 over 3 squared. And now just do 3 squared, which is 9. You get 1/9. Okay? Comments or questions so far? Okay. If it's hard to see, it's -4 to the -3rd power, in parentheses, all to the -1st power. So, what property do you see illustrated here? There's a whole bunch of different ways to do this one. What property do you see? What jumps out at you? I'll give you a hint. It's Mr. Gall's favorite property to say out loud. Oh, now all of a sudden everybody knows. What's my favorite property? Mullally? Power of a power! Power of a power. So we have a power, power being brought to another power. Power brought to another power. What do we do with the exponents when you have power of a power? I'm just going to keep saying it. What do you do with the exponents when you have power of a power? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people who know. Avanti. Yeah, you multiply them. So this becomes -4, and it's a -3 times a -1. It all of a sudden becomes a +3. Now just evaluate. -4 times -4 is 16. 16 times -4 is -64. Comments or questions on how we did that? Okay? Part D. This is here to illustrate one idea. A negative exponent means reciprocal. Since it's to the -1st power, the power doesn't really do anything, right? In other words, let's just use a simpler example. 2 to the 1st power is 2. 8 to the 1st power is 8. 9 to the 1st power is 9. 1,000 to the 1st power is 1,000. So a power of 1 doesn't really mean anything. But the negative sign does. The negative sign means reciprocal. So if you have anything to the power of -1, all it means is flip it. That's all this means. Flip it. So 1/3 to the -1st power is going to be 3/1. But you know that we don't write the 1 on the bottom, so that's just a fancy way of writing a 3. That will work with anything. If you have 1/x to the -1st power, that's just going to turn into x. Okay? So it doesn't really matter what's on the inside. If it's just a simple fraction to the -1st power, it just means flip it. Okay? Comments, questions on what we've done so far? Comments or questions on any of these? All right. Checkpoint number 1. Let's see how you do. 2 questions. You got a minute. All right. What do we get for part A? Juliana, Destiny, Martin. What'd you get? 1. You agree with her? Okay. That is the correct answer. It is 1. Very good. Part B, what did you get? You got Abigail, Tyler, and then Samantha. Okay?
1/64.
Okay, so you two agree. 1/64, the correct answer is 1/64. So, how did you do it? Part A, what did you do? What did you do, Cornelia?
I multiplied and I added negatives equal to 2 and I got 10 to the 0th power.
Very good. If you just multiply these two together, same base, you add the exponents, you get 0, and that's a 1. Anyone do it differently? Good. Any questions on anything? Good. So now we'll bring it to the next level. Here's the real work of the day. That was really just the introductory work of the day. Now I'm going to introduce my alternative way of looking at things. It's really nothing different, but I'm going to say it a little bit differently. Don't write down part B, just write down part A. I have been telling you for 2.5 lessons that when you write any of these problems down, when you're starting a question, write it with multiplication dots in between everything. It was actually to help you, but it was really because of this. So, part A, 3 times x to the negative 4th, y to the negative 5th. Rewrite with positive exponents. When you write the question down, you should have written 3 times x to the negative 4th times y to the negative 5th. Now, you can use what we've done so far, or you can use my alternative way of thinking, which is, first of all, you understand that everything is a fraction. Everything in the entire world is a fraction. So really, there is a fraction bar right here with a 1 underneath it. Everybody should already know that. So here is my method. Anytime you have anything to the negative exponent, it has to move to the other side of the fraction. Right? So let's look at the x to the negative 4th. X to the negative 4th is on top. It has a negative exponent. It has to move. It moves to the bottom. So it is going to come down here, and we're going to flip the sign to positive. So it's going to become x to the 4th on the bottom, and it's going to disappear from the top. Now, look at the y to the negative 5th. That is on top of the fraction, and it has a negative exponent. It's got to move. Negative exponents have to change. So we're going to move it to the bottom and flip the sign so that it's positive. On the bottom, it will be y to the 5th, and that will disappear. You only move negative exponents. Negative exponents. So now rewrite it in simplest form. The 3 is still on top. X to the 4th, y to the 5th. Now, here's the problem that students have. So I'm going to erase this side over here so I can use this space for a moment. And then I'll put it back. Here's the problem students have. They don't follow my advice. They write down the question like this, and they go, oh, Mr. Gallant said that everything with a negative exponent moves. So this is going to move, and that's going to move. So I end up with 1 over 3x to the 4th, y to the 5th. What mistake was made? Austin? You weren't supposed to move the 3. But the human mind, and young people especially, we tend to attach the number to the letter, because I've been telling you that since the beginning of the year, that you can't really separate those two. But that's for some different concepts that we talked about. So students start moving things together, and you're not allowed to do that. You only move the negative exponents. Here is the other issue. I'm going to make up a new problem. Negative 2x to the negative 8th, z to the negative 3rd. So my students go, okay, I got it, Mr. Gout. You said move the negative exponents. So this is going to all disappear, and it's going to all move to the bottom, and it's going to be 2x to the 8th, z to the 3rd, and there'll be a 1 on top. So what mistake did I make? Tanya?
Well, you weren't supposed to bring the -2 down.
Yeah. But I didn't bring the negative 2 down. I made it positive.
But it's a totally different term. It's not with x to the negative.
Right. But it was negative on top, so I was supposed to move it. Negative exponents, you have to move, right? Ashley?
The -2 isn't an exponent, so you can't move it.
Oh. It's not an exponent. A lot of my students learn new rules and they start applying it to things that they're not supposed to apply it to. So this is totally incorrect as well. Can't do that. Just because it's a negative number does not mean it moves. Negative exponents move. Okay? Tyler, yes.
That's because it's like saying -2 to the first power, so the exponent is positive.
That's right. But and you're right, but what I've noticed over my years teaching this is that students start looking at negative numbers all the same way. Students start going, oh, Mr. Gow, it's a negative number, I move it to the bottom. Negative number, I move it to the top. Negative number, negative number. We're only talking about negative exponents, not all negative numbers. Okay? Comments, questions? Comments or questions? All right, part B. Again, when you write it down, you should be writing 1 over 7 times y to the -4th. This time, we have a negative exponent on the bottom. It's got to move. So you move it to the other side of the fraction. It's on the bottom. We need to move it to the top and make the exponent positive. So it's going to disappear from the bottom, and it will show up on the top as y to the 4th. And that's all you can do. So we end up with y to the 4th over 7. Comments or questions about that? Comments or questions? Okay, so let's kick up the complexity a little bit and now start incorporating everything you've learned. And again, I encourage you to try and view it as a puzzle. What method could you use, or what properties can you use to figure it out? There's more than one way to figure it out, and you will always arrive at the same answer as long as you follow the rules correctly. Ashley? You said my favorite one. Power of a power is what I see. Of course, when you wrote down the question, you wrote the multiplication dots in between everything to help yourself. And we're going to do power of a power. So the 2 is going to get the -3rd power. The x to the 3rd is going to get the -3rd, and the y to the -8th is going to get the -3rd. So rewrite everything. 2 to the -3rd power times x to the 3rd to the -3rd. What's that going to become? Avanti? Power of a power, we're not adding, and you were the one who helped us with this earlier. That's right. So it's times x to the -9th. Times, and what about y to the -8th to the -3rd? What do we get when we do that? Homera?
Y to the 24th.
Yeah, y to the 24th. We have negative exponents. negative exponents are going to move. It's a fraction with a 1 underneath. Any negative exponents have to move. So 2 to the negative third is a negative exponent. So that has to move to the other side of the fraction. It's going to come down to the bottom. This is going to come down here. And this is going to turn positive. So down here it will become 2 to the third power. And now it's going to disappear from the top. What else is going to move? Brandon?
X to the negative ninth.
Yeah, x to the negative ninth also needs to move. That's a negative exponent. So it's got to move to the other side of the fraction. So it's going to come down over here, and we're going to make it a positive exponent. It will become x to the ninth, and it's going to disappear from the top. Now simplify anything that can be simplified. The only thing left on top is y to the 24th. On the bottom, 1 doesn't really matter. 2 to the third is 8, and we have x to the ninth. 8x to the ninth.
Couldn't we simplify the 2 to the negative third on the top first, and then it wouldn't be a negative exponent?
How would you simplify it?
Well, okay.
No, I'm asking, how would you simplify it? You can, but I would encourage you to stick with the idea of moving all the negative exponents. Here's the idea. Here's what we want to do. We want no negative exponents. Get rid of them. We don't want to deal with them. Get them out of the question immediately so that you can then do all the things that you've become an expert at. So just get rid of all the negative exponents by moving them to the other side of the fraction. Okay? Comments, questions, concerns? Okay? No other comments, questions, concerns? Okay, look at part D. Was it this class that we talked about the optical illusion of the vase?
Yeah.
So we have the vase, and there's two women looking at each other, and some people see the vase, and some people see the two women, and usually if you look at it long enough, you'll see the other, whichever one you didn't see initially. So I want you to look at part D. I don't want you to solve it, I want you to just look at it. I don't want you to simplify it, I just want you to look at it. I shouldn't have said solve. So, what do you see? You haven't done anything yet. I'm asking, what do you see? Destiny, Arun, and Tanya, what do you see?
That x negative 6 is on both sides, on both numerator and denominator.
So that's an observation. You just good. Arun.
I'm thinking that because there's an x and negative 6 on the numerator and the denominator, I think that it should be like simplified.
How?
Because it cancels each other out. Because if there's -5 for each x, that means that it's basically 1 over x to the 5th for both sides.
Mm-hmm.
And would that cancel out? That'll be basically the same thing as saying 1 over 1 or 2 over 2.
Maybe.
Well, x to the negative 5th power is on both sides, so they would cancel each other out, and negative 12 and 4 have a common factor of 4, and they would be simplified.
Very good. So initially, when you look at this, I initially saw what Ashley saw on the last question, which was power of power. Where you've kind of been trained to say, oh, power out here, so I got to go like this, and like this, and like this, and like this, and do all of that. But I would hesitate for a moment and look inside. Because PEMDAS says you're supposed to do what's inside parentheses first, if you can. In this case, there was nothing to simplify inside the parentheses, but everything that all three students said was correct. Anytime you have something on the top and something on the bottom that are exactly the same, they cancel each other out. So this will cancel with that. Tanya was right. Negative 12 and 4 have a common factor of 4. So 4 divided by 4 is 1. Negative 12 divided by 4 is negative 3. And wow, my job just got a whole lot easier because now I just have to do negative 3 to the negative 4th power. And all that means is the reciprocal of that. So this becomes 1 over negative 3 to the positive 4th power. And now just simplify negative 3 times negative 3 times negative 3 times negative 3. So what do you get when you do negative 3 to the 4th power? What do you get, Juliana? You get, let's see, negative 3 times 9 is 27. Yep, you get 1 over 81. So look at the original expression and look at what it turned into. So that's not a normal case, but it's going to happen a decent number of times. Okay? Good, we're doing an excellent job. So checkpoint number 2. Let's see how you do with these two. This time you got 2 minutes. Still have a number of people working, so take another minute. see how he did. Part A, what did you get? 1, 2, 3, 4, 5 confident people, semi-confident person. Tyler, Austin, and then Brianna. What'd you get, Tyler?
I got x to the 20th power, y to the 60th power over 1024.
Okay, what'd you get?
X to the 20th power, y to the 60th power over 1024.
So I'm pretty sure that's exactly what he said. Brianna? You got the same thing? That is the correct answer. Part B, what did you get? We will start with Brandon, Destiny, and then we will go to Nicole.
I got 12 to the second, y to the fourth over x to the fourth.
Okay.
I got 144 times y to the 4th power over x to the 4th.
Okay, so it's almost the same thing. He said 12 to the second. Okay, go ahead, Nicole. It comes out to 144 y to the 4th over x to the 4th. Comments or questions on either of these?
I got viewers for A. I got the top part right. I just don't know how I got 1024.
What did you have on the bottom?
I think that's like a multiplication one because I got 100.
Okay. Okay, let me come look at yours, because if you got the top part right and you had a number on the bottom, then you just must have made a small mistake.
I was doing the multiplication without a calculator.
Okay, so then you probably made a small mistake. Okay. All right, so draw a line across your paper. Your classwork is page 84, 26, 25, 24, 23, 21, 20, 19, 12, and 10. Okay, colored pens, and let's see how we did. Number 26, 4 pi over 375. Number 25, 1/20th of an inch and 2/25ths of an inch. If you can't see, I'm going to read these out. 24. X to the 3rd, y to the 7th over 3. Number 23, 1 over 4, x to the 6th, y to the 5th. Number 21, d to the 5th over c to the 3rd. And number 20 comes out to 1. And number 19, x to the 12th over 64, y to the 6th. Number 12, 625, and number 10, 1 over 100,000. Comments or questions on any of these? Destiny and then Nirmala.
Remember the 25? I put 1 over 12.
Okay. The answer is 1 over 20.
No, the B
Oh, you put 1 over 12.5? Oh, I'm sorry, I see now. Okay. Yeah, I guess those are equivalent, so that's okay. Okay, number 25 is confusing because of the size of the numbers, and in this case, it's because the numbers are so small. So let's change the situation, okay? Let's say textbooks, okay? If I said that this textbook is 2 inches thick, okay? So I want you to forget about this question. And I said that we have a textbook that was 2 inches thick. How high would 5 textbooks be? 10. How did you do that? Multiplied it by 5. Okay? 2 times 5 is 10. Now let's bring back the original question. Total thickness of 5 sheets of paper. The paper is 100 to the negative first power inch thick. So instead of a 2-inch thick textbook, we have something that's this thick, and we have 5 of them. So now simplify. What you learned was 100 to the negative first power really means that it's going to be on the bottom. So now we have 5 over 100, put it in simplest form, and you get 1 over 20. Okay? The second question, the second part, part B, was the same question, except instead of a 5, it was 2 to the third power. So now it becomes 2 to the third power over 100. Okay? Does that make sense now? Okay. Very often when you have numbers that are huge or numbers that are tiny and you're not sure what to do, change the question to something simple and see if you can figure out what to do. It's a recognized problem-solving method called do a simpler problem. Change the problem to something simpler, figure out how to do it, and then apply the bigger numbers. Okay? Any other comments, questions? Your homework is page 522, 4 through 44 even, and 50 through 56 even. We are not doing a lesson on 8.4 per se, but we are going to actually do some of it during the review, and you need to read the next section. And you are going to have a test on chapter 8 on Monday. We will review on Friday, test on Monday.